Wouldn't it be cool if we had something like Google Street View, but for our galaxy instead of our planet? What if I tell you that we already have it for almost 10 years? I think everybody should know about it. Let me show you. So what we're looking at right now is called Photopic Sky Survey. And I know the name probably sounds pretty boring, and I guess it's because initially it was purely scientific purpose to make those surveys to explore big regions of the sky, and they call it also astronomical survey. So on the Wikipedia page for astronomical survey we see that it has a list of a bunch of surveys, and the one I'm showing you today actually ironically is the only one which doesn't have a dedicated Wikipedia page, which is shame, I think, because this one is in my opinion, is most useful to average person like me, like us, not scientists, who just want to see surrounding space in the visible light. And most of other surveys are done in the like different spectrums, not only visible, like X-ray or infrared, so they are not very useful to just look at them, and probably I will not even understand what they represent. So what's so special about this particular sky survey? I would say, first of all, it's a 5 gigapixel 360 degrees panorama of surroundings of our planet, basically. And it has the all-night sky which we can possibly see from our planet, which is fascinating. And yeah, we probably saw a lot of different 360 degrees panoramas already, but why I compare it to Google Street View is because it also has this mode which we activate by pressing I, and there we see this little radar appears, which shows us what is our field of view, current field of view, where we are looking at in our galaxy, and this position of our solar system, which is also really cool. It gives like amazing, incredible perspective, which we don't get usually from any other tools, or I don't know, virtual observatories or something like this. So what this mode activates beside this radar is also descriptions of constellations we see, and not only constellations, different deep sky objects, like this one is Cygnus. We can see that it's a North American nebula, which opens for us a Wikipedia page where we can read more about it. And I think it's a really cool tool for people who are interested in astronomy, even astronomers, astrophotographers, to just understand what they're gonna see or where to look for an object. And yeah, it's really cool. I used to use this tool for planning my astrophotography sessions, to like sort of to understand in advance what to aim for, what I'm gonna see, and so on. And another thing is that it also gives us amazing perspective on the parts of a Milky Way which we don't see in our, for example, I live in a northern hemisphere and I don't know what's going on in the southern hemisphere, like those Magellanic Clouds, our satellites, galaxies, and yeah, other different objects which are very fascinating to look at. And why I think everybody should know about this Photopic Sky Survey is that it really gives unique perspective, as if we just removed like a solar system from the place where it is right now, and we just put ourselves there, and like the way we would look around our galaxy and understand our current place in it. So we clearly see that we are in the plane of a like galaxy disk, so everything which is in this plane, the most action is happening here. Like you see different objects, different nebulosities, and mostly, yeah, all of that is happening more or less in the same plane. And we can also see like up from our disk, and here we see basically only stars which surrounds which surround our sun, and we can also see galaxies, other galaxies from here. And yeah, it's really cool that, for example, Andromeda galaxy is somewhere, you see, a bit below our disk, if it's even possible to define what is below or above in the space. And Pleiades constellation, not constellation but cluster, is also a bit off the plane of the disk, so it's a little bit below. So it's really cool to just understand where all those objects are positioned relative to us, relative to the galaxy plane. So yeah, we can't call it yet the full analog of Google Street View, because we can't move here. Actually, yeah, it's the only perspective we have so far, and probably later, once humanity explores the space around it and start traveling, we can build more accurate maps, and actually we will see here like arrows, so we can, you know, just move around our galaxy and see things from different perspectives. But for now it's the best what we have. I think I've never seen anything like that, and it already exists for 10 years. I think really few people know about it. That's why I'm trying to spread knowledge about this tool. It's really cool. So let's now talk about how did it come to life actually. The most fascinating fact about this sky survey is that it was actually done by a single person. His name is Nick Reisinger. I believe it's a correct pronunciation, correct me if I'm wrong. So he's a photographer and designer from Seattle, Washington, and yeah, it all started with a blog post he wrote on February 17, 2011, and he described how he quit whatever job he was doing at the time. There are no details on this part, and decided to go to the journey, to take a journey to actually capture the whole night sky like it was never captured before. So he had to take 37,440 exposures, and he had to split the sky in the 624 pieces in order to then stitch them together to get this panoramic view. And it's truly incredible work, which took him I think around 10 months of just traveling and making sure he captured all possible piece of the sky. He traveled 45,000 miles by air and 15,000 miles by land, and he went to the deserts, to the to the South Africa, but probably sometimes there were pretty harsh conditions, and he described it in a different blog post. So yeah, I encourage you to read this thing, because there's not a lot of information about this sky survey. From what I understood, he made it in order to create after an iOS application called Sky Guide, and which is probably the main consumer of this sky survey. But he also left this interactive 360 degrees map for us to explore, for those who don't have this application. And what else? The cool thing is that it also took 2 months of time just to process all the collected data. It's really crazy amount of time and computational power. He had to employ 4 terabytes of data, and it's 2010, 2011, which you can imagine, now we have more affordable SSDs and so on, everything could be faster, but at that time I believe it still was pretty slow back then. So it's just enormous amount of work. And in another blog post here, he actually shares what exactly he used in order to obtain those images. And this is also, I think, the setup which nobody ever seen before or after that, because it has simultaneously 6 cameras, six CMOS cameras, which are already pretty expensive. Each one now costs around 4K US dollars. So why did he use this particular setup with the 6 cameras at the same time instead of using one camera, which could be much easier probably to operate and maintain? I think he wanted to get the best possible quality from this setup, and each camera is actually monochrome, which is much better to use in astrophotography because it gives much better signal to noise ratio and captures more signal. That's why he had to use a monochrome camera. And in order to use it, you have to shoot the same target with several different color filters in order to assemble it back to the final colorful picture. He listed all the equipment he used for that, and even software. So what I was talking about is that for each camera he used the separate filter, and it was a set of LRGB, so luminance red, green, blue filters, plus H alpha filter for a hydrogen for all those red nebulosities, and you can see there's a lot of them. And the thing is that here we see 6 cameras, and some people actually question, like we see here 5 filters, why there are 6 cameras? And recently I found answer. There was a picture from some astrofest from Washington State, I believe, which you can see on this picture more detailed. Each camera has its own label, so there are actually 2 cameras using H alpha filter, I believe, to just collect as much signal as possible during the shortest time possible as well. So in order to get all of this redness, which is a lot of it here, you just can see that almost in every region of our galaxy we have a lot of hydrogen which needs to be captured. So it was pretty smart move, and I think this is really unprecedented setup for astrophotography, like a dream setup, because you save time on using 6 cameras simultaneously, and you get the best possible quality from monochrome CMOS cameras. What I also did is that I tried to simulate this field of view he could get with his cameras and lenses and in Stellarium. So it's basically pretty small region. Imagine to cover the whole sky with this little square. It took him 624 images. For each astrophotographer out there, everyone knows that it's even hard to get one single picture being clear without gradients, without colors looking unnatural. But imagine having these 624 images in order to stitch them together so they look exactly seamless. It's just incredible work. Now, bad news. This interactive 360 degrees panorama requires flash to be installed, and yeah, it's 2020 right now. People don't use flash anymore. It's considered harmful by many browser vendors, and that's why Chrome, for example, even put here the warning that Flash Player will no longer be supported after December 2020. And I don't know what's gonna happen to this particular panorama, to this sky survey, because it's really unique in many senses, and I believe that anytime sooner there's not gonna be anything like successor of it, some other person trying to recreate something like this with a better resolution or quality, because it takes just enormous amount of time, work and money just to get there. And having all those traveling restrictions right now, we just need to really appreciate what we have and just spread the knowledge about it, I think. I'm already trying to contact Nick Reisinger to offer him probably some help or idea to migrate this website to the HTML5 so it can be accessible from all the browsers, from mobile devices. I think it just needs to be done because in the January it's gonna celebrate 10 years already, and I think it's still relevant up to this day, and we should not let it die because of the Flash player. And even if Flash player is still around, really people are scared to install it because like browsers encourage you not to install it in any circumstances. That's why this masterpiece should be accessible for everyone without installing it. The good thing is that I found that I can control some of the API of this Flash player from my browser developer tools, and I can change the camera angle, do some animations. And if I don't get success to convince Nick to migrate this website to HTML5, at least I captured some really cool angles and assembled it for this piece.